Hello everyone, welcome to yet another video of measurement and instrumentation series. In this video, we are going to see about measurement of low resistance using Kelvin's bridge, particularly Kelvin's double bridge. Kelvin's double bridge may be used for precision measurement of four-terminal low resistances. Four-terminal resistance have two current leading terminals and two potential terminals across which the resistance equals the marked nominal value. This is because the current must enter and leave the resistance in a fashion that there is same or equivalent distribution of current density between the equipotent surface used to define the resistance. The additional points also eliminated for any contact resistance at the current lead in terminals. It is actually a modification of Wheatstone bridge in which the errors due to contacts and lead resistance can be eliminated. Measuring low resistance from 1 ohm to micro ohm will include errors due to effects of connecting leads in Wheatstone bridge. Hence, Kelvin's bridge is used. The circuit shows the basic form of Kelvin's bridge, wherein which the circuit is very similar to a Wheatstone bridge. It consists of 4 arms of resistance R1, R2, R3 and R4. A galvanometer is connected at the unknown nodes. Here, one end of the galvanometer is connected to a point P. A Kelvin bridge will give the exact location or exact point where the galvanometer lead needs to be connected so as to eliminate the addition of lead resistance to the unknown resistance. Assume a point M, N and P. Let the resistance between P and M be RPN, RMP, and let the resistance between N and P be RPN. The total resistance be RY. Now, if the galvanometer is connected to point M, then Ry is added to Rx, which is the unknown resistance. Hence, the unknown resistance value measured will be of higher value, which leads to an error. If the galvanometer is connected to point N, then the unknown lead resistance Ry will get added to the standard resistance value R3, which results in lower value of Rx. So by connecting the galvanometer lead at M or N, it leads to an error in the measured unknown value. Either it gives a higher Rx value than the actual value or a lower unknown resistance value which is not the actual value. If the galvanometer is connected at point B, the exact midpoint between M and N, in such a way that the following condition is true: RNP by RMP is equal to R1 by R2. Hence, for bridge balance equation, Rx, the opposite arm resistance, should be equal. So, Rx by RNP is equal to R1 by R2 into R3 plus RMP. Therefore, we need to find Rx. So, Rx is equal to R1 by R2 into R3. So, from this equation, it is obvious that only the standard resistance and fixed resistance are included in finding the unknown resistance value, whereas the lead resistance values are eliminated. And that is why we are going for Kelvin's bridge for measurement of unknown resistance value, wherein which the addition of lead resistance are neglected. So by connecting the point at exactly at P position, we can neglect the addition of unknown resistance value or the effect of lead resistance in the unknown resistance. A Kelvin's double bridge incorporates the idea of a second set of arms, namely P and Q, and hence it is named as Kelvin's double bridge. The known resistance small p by q is made equal to the capital P by Q. So under balance condition, there is no current through the galvanometer, which means the voltage drop between the terminals A and B, that is capital EAB, is equal to the voltage drop between the terminals A and C, which is EAMD. So by substituting the values in the bridge balance conditions, we can find the unknown resistance value, which is capital X is equal to capital P by Q into S plus QR by small qr by P plus Q plus R into P by Q minus P by Q. So this is used for measurement of low resistance value, which is of the order micro ohms. So in this video we have discussed about measurement of low resistance using Kelvin's double bridge, and I have displayed a sample problem along with its values. So do try this sample problem and check whether you receive the same unknown resistance value. Thank you for listening.